All right, so hello everybody. My name is Sam and I welcome you all into today's session where we will go ahead and discuss about data science and binary model classification. First of all, I would like to thank all of you for finding out time from your busy schedule and attending today's session. So thank you, first of all of you. This session is brought to you by EIMT, European Institute of Management and Technology, powered by Career. So before we go ahead and get started, just to give you a small brief introduction about us, EIMT, European Institute of Management and Technology, is situated in the heart of Switzerland in Zug. It's a 21st century Swiss education institute contributing to a sustainable society, ensuring student success along with academic excellence, and managing the institute efficiency in terms of organization and allocation of resources. Engaging with stakeholders through partnership, collaborations, company placement, or membership activities, and contributing to the academic and business body of knowledge through research collaboration, teaching, and public dissemination of finding. The webinar that we have today is brought to you by Careera. So we would also like to go ahead and thank Careera for the same, for this opportunity for us to go ahead and get connected with you. Careera is one of the leading edtech companies all across the globe with students from more than 60 countries, more than 1 million learners, and 500 plus hiring partners. Now, for today's session, I have with me Paulo Cisne Rios. He is a data scientist working with Kaizen, located in Geneva, Switzerland. Just to give you a small brief overview about him, he brings with him more than 20 years of work experience, including more than 15 years in data analytics. He has technical and leadership expertise in using advanced data analytics, that is data science, machine learning, deep learning, natural language processing, time series analysis, with powerful impact in fraud detection, compliance, marketing, insurance, finance, banking, consumer experience, healthcare, and pharma. He has been providing training and learning for a very long time and has been working in this industry also. So without further ado, let me go ahead and pass on the mic to him so that he can go ahead and get this webinar started and take you into the world of data science. Paulo, can you hear me?
Yes, I can. Can you hear me?
Yes, I can, loud and clear. So let me go ahead and pass on the rights to you. Just going to make you the
Yes.
host as we speak. So I guess you
Okay.
can share your screen right now and we can go ahead and get
That's
started.
now nice. Okay, so now can you all see me?
Well, I
Uh,
can for sure. Guys, if
yes,
you're able to see him, just type in yes in the chat.
yes. Okay, so you can. Wonderful. So we are going to see today a very important measure for binary model classification. How we achieve that. This is not so well understood by many. So it's a very good opportunity for you to see more about it and to understand how to do a proper binary model classification. We're going to use Python. So I'll move on now to my presentation. So just a moment. So share screen and okay. Okay. So now let's start the presentation. Can you all see, right? The screen. So we're going to see today about binary model classification, how to find the optimal threshold. You're going to understand all what I mean by threshold and what I mean by optimal. We're going to have a Q&A at the end of our session so that we can move along. But if there is anything important, just let me know. But otherwise, we are going to do a Q&A at the end. Let me see if you all, okay. So let's start now. So the first thing is, as has been said, I have over 20 years experience, generally speaking, so including web development, data analytics, and so on. Out of them, 18 years is of my professional experiences in data analytics, especially in Switzerland, where I live. I have worked with global companies and with international teams. I have over 12 years of experience with data science. I worked with machine learning, deep learning, NLP, time series analysis, different cloud platforms, algorithm trading. And one thing that I find very important that one day we can have a webinar about is model explainability. This is very key in many projects, that people understand why the model came to that conclusion. And I have over 15 years of experience with SQL, which I advise you to learn. It's very important in data analytics, and over 12 years of experience with Python. I have worked in many areas here in Switzerland, especially in finance, banking, insurance, trading, global supply chain, logistics, marketing, healthcare. And my LinkedIn profile that have over 20,000 followers is here. You can see on the screen. And please feel free to join me there. Okay, you are welcome. So we are going to learn a few terms in our way to learn more about binary model classification. What is the best way to do binary model by classification? We're going to learn what is a confusion matrix, what is precision, what is recall, what is a F1 score, what is the precision recall trade-off, and what is the precision recall curve, where this is where we're going to find the optimum threshold. So generally speaking, what is a threshold is, for example, if I make a classification, usually all the models, they return probabilities, and the default threshold is 0.5. So it means that if the probability of a positive class is, like, for instance, a positive class could be it has a disease, or is a spam mail, or is a fraudulent transaction, so, or is a client that is going to churn. So this probability is when it's over 0.5 is considered positive, and when it's less than 0.5 is considered negative. So 0.5 and up is positive, and less than 0.5 is negative. It means when the probability that the model gives is over or equals 0.5, that classification is considered belonging to the positive class, like it has a disease. And when it's less than 0.5, that probability is considered as belonging to the negative class. It has not a disease, or it's not a spam. And that threshold, the 0.5, is the default, but you can change it. Not only you can change it, and this will change completely the performance of your model, it can also affect as well the precision recall that we're going to learn about. And then, and this is the most important, although there is a trade-off in precision recall, there is an optimal threshold that you can find and that you should use. And we're gonna today see how we can find this optimal threshold. So I kindly ask you that you leave your questions more towards the end. We have a Q&A at the end, so that we can move forward, because we have many participants. So we're just going to move forward, but don't worry if there's something that's not clear. I'll have some short breaks for you to ask some questions, not only at the end. Okay. So the first thing we're going to learn about is the confusion matrix. So the confusion matrix, as you can see, is a matrix where on the left we have the true labels, and in the columns we have the predictor labels. So what is this about? So you see 4 squares. You have 0 and 1. The two labels, 0 and 1. 0 is negative, 1 is positive. And the predicted is 0 is the negative one, and 1 is the positive. 0 means no disease, 1 has a disease. 0 means no spam, 1 is a spam email. 1 is a fraudulent transaction, 0 is not a fraudulent transaction. But then what you see, where 0 and 0 means that the model, the yellow one, the model classified as 0. What is 0? So it did well. And in the green one, the model classified as 1. What is 1? So that was very good. But we have the other pink ones. The pink ones, the one on the top, which is 53, the number, it means that in 53 instance, there was actually 0. They were belonging to the class 0, which means they belong to the class of, it's not a spam mail, it's not a fraudulent transaction, it's not a disease, but the model classified them as 1. So it was a mistake. And in the other one below, the 59 instance, in this case, the true class is 1, and the model classified as 0. So there was a mistake. And we're going to learn about this now. So what is true positive, true negative, false positive, and false negative in the confusion matrix that we have just seen is, I will go back here. So in the case of 96, the yellow, so it is a 0, the true label. So in the data, the label, the correct label is 0, because we have a binary classification. It's either 0, 1, is either spam or non-spam. The email is either the patient has a disease or not have a disease. The transactions is fraudulent or is not fraudulent. So in this case, we have a 0 and 0. So that is true, it was correct. And in the case of 1, it was also correct. But in the case of 53, we have a false positive. It says that is 1, but it's not 1. It was actually 0. So the 53 is called a false positive. It's called positive because it's 1, and it's called false because it's not correctly classified as 1. Now the 59 is called a false negative because it's classified as negative, as 0, but it's not negative. It's actually 1. So this is called a false negative. The 92 is a true positive because it's 1, but it's classified as 1. This is a green box. The yellow box is 0, and it's classified as 0. So that is a true negative. And this is the definition of true positive, true negative, false positive, and false negative. For you to remember what is what, just think about true means that is equal to the true value, and false means that the model is giving a classification that is wrong. So if it says false positive, it means the model says that it's positive, but it's wrong. In the true value, it should be negative. And if the model says false negative, it's the same. It means that the model says that it's negative, but it's not correct because the true value is the opposite, positive. But then all these calculations that you see here in this confusion matrix, this example, they are all using the probability that the model gives So the model gives a probability between between 0 and 1. And when the probability is equal or greater than 0.5, then it's considered a positive class. And when the probability is less than 0.5, it's considered the negative class. So the 0.5 is called the classification threshold. And as I told you, can vary between 0 and 1, because the model outputs a probability that a certain instance belongs to a class. So this probability is between 0 and 1. So the classifier, the model performance varies as the thresholds change. And then there's the optimal threshold that you can have for, and this optimal threshold depends on the data on each case, but I'll show you how to calculate. The optimal threshold that you can have that will give you the best precision recall trade-off that you're going to learn about, that gives you the best that your model can perform. So if you don't do anything, the results you get from your model is all based on this 0.5 classification threshold. But you are able to change this threshold and get a better performance from your model. And this is what we are going to learn today. So let's learn first about what is precision, what is recall, and what is the precision recall trade-off. So precision is the number of two positives that we saw in the matrix divided by the total of positives. I mean, true positive plus false positive, as you can see here in the bottom. So the precision answers the following question: what proportion of positive predictions were actually correct? So out of all my positive predictions that I said that people are sick, or that the emails are spam, or that these transactions are fraudulent, out of all my positive predictions that the model made, how much percent are correct? So for example, in the case of an email spam classifier that is going to classify the email as spam or not, if the system classified 10 emails as spam, but the mean predict as positive, and only 5 were actually spam, so only 5 out of 10 is correct. So the precision is 50. So the precision is all about out of my positive predictions, how much percent are correct, okay? Now we're gonna go over to recall. Recalls answer a different question. What proportion of the actual positives was identified correctly by the model? So now, instead of looking at all my positives that the model classified, I'm looking just at the two positives. So as you can see in the definition of recall, recall is the two positives divided by true positives and false negatives. So what it means is, from the pool of all actual positives, recall finds the fractions of those that the model classified as positive. So as an example, if there were 10 spam mails, actual positives, in the entire data set, and the model classified 7 of them as spam, predicted as positive, the recall would be 70%. So recall is a different measure. It looks at the classification from a different point of view. And what is the precision recall trade-off? Is that if you have a high precision, it may leave out some extra positives, but what intends to return is higher accuracy on the positive class. On the other hand, if you have a high recall, it might give you a lot of misclassification of actual negatives, but it most always will correctly classify the actual positives from the data set. So you cannot have both very high. So if you have a high recall, you're going to have a low precision and the vice versa. So each one to choose, whether you want to have a high recall or high precision, depends on the problem that you are using. Generally speaking, optimizing precision typically reduces recall and vice versa. And you are going to find the best balance using the optimal threshold that you can have of precision and recall. There is another measure. This one is a measure that is called the F score. Actually, it's the F1 score. They measure the performance using both precision and recall. This is called the F1 score that we're going to calculate as well. So when you are dealing with a customer, trying to solve a problem, you need to look at this. You need to see what is more important in my case, is the precision or the recall. And this all depends on each case. For example, whether it's more important, if you look here at precision, where it's more important that you get the maximum number of actual positives compared to all the positives that you have calculated. So then if the precision is the most important, that you get out of all your positives, the majority of them are correct, then you should use precision. If on the other hand, the most important is the recall, that means the proportion of the actual positive, how much was correct, how much you identified as correct, then is the recall. But there'll be always a trade-off. You cannot have both high precision and high recall. And the F1 is a score that takes in consideration the two. So when you are working in a classification, in a binary classification, you should not look at precision, at accuracy only. Because imagine if I have a case, where 5% is is negative, 95% of the instances are positive, I can just say, oh, okay, everyone is positive, and I have 95% precision, accuracy. Even worse, if I have 99, a very imbalanced model, I have 99% of the instance positive and just 1% is negative. If I say, well, it's a dummy classifier, I say, oh, well, everyone is positive. So accuracy, 99%. So accuracy is not a good measure when you have a binary classification. The best measure is to look at precision and recall, and to see the optimal threshold that you can have for your classification that will affect the precision and the recall. So we can have a visual look at the precision recall trade-off by plotting a precision recall curve, which is calculated by creating class labels for probability prediction across a set of thresholds. So imagine the threshold is always what is going to determine whether an instance is positive or not, because the model is going to give you probabilities of being positive. If you don't do anything, you're going to have the threshold at 0.5, but otherwise, you can use different thresholds, and you're going to see across different thresholds in the precision recall curve what the precision recall looks like. So there'll be a line plot showing this, and in this curve, we're going to see the optimum threshold. We're going to have a live code where you can code along with me, and we're going to see how we find this optimal threshold, how we plot a precision recall curve, how we display a confusion matrix, how we calculate in the code the precision, the recall. We're going to see this right after this presentation. So before we do that, before we see this case, I would like to tell you a little bit about any data science project. What you should observe is that you should have these phases in any data science project. You have data loads. That's the first. You read the data, either from database, either from a CSV file. But you read or from a data warehouse. You read the data. You explore the data. You do data preprocess, like encoding the data that is not in numeric format. You do feature engineering. You do feature selection, where you select the data as well, and you do model training and the model evaluation, right? These are the usual steps. But there are some steps missing that I want to point out to you, is that these are not the most important steps. The data exploration, preprocessing, feature engineering, feature selection is very important. It can change your model performance if they are not done well. But there is something even more important, is before starting data science project, you need to answer the question, what I'm going to answer with the data? What is my predictive analytics all about? You know, what I want to answer? I want to answer what? The question is about finding from some data whether a person has a disease or not. This is my goal, is finding fraudulent data, whether I have fraudulent transaction, yes or no. And to have data to be able to train a model to predict that in unknown data in the future. You have that data. And who is going to use? Is a doctor, if I predict a disease, is some business users, if I predict a fraudulent transaction. And at the end, once you know your stakeholders, you need to know how they work, how they're going to work with your predictions. And deployment and integration in the company technical and business environment plays a very important role. So both the beginning and the end, you should always take in consideration. You should really know if your answer is what they are looking for, whether the stakeholder are looking for that question that you are trying to answer. You should look that you have the data that answer that question. And at the end, you need to have a solution that integrates well with the way they work and with their technical environment. This I really point out to you because I have seen many failed projects just because they did not pay attention to the question and to the deployment and integration, and they did not pay attention to the needs of the stakeholders. So this I want to point out to you. So what we're going to do today, we're going to have some live code where I'm going to show you all about the different steps for model training in binary classification. We're going to see how we create a confusion matrix and how we calculate precision recall, the F1 score, and how we plot a precision recall curve. And most important as well is how we find the optimal threshold. And we are going to do this code live. We will code along. And we're going to use for that Jupyter Lab. I don't know if you're familiar with Jupyter Lab, but the libraries that we're going to use, the Python libraries, it's matplotlib, pandas, and Numpy. These libraries, and also I didn't mention here, sklearn. These libraries they're all standard with Anaconda. So I suggest that you download the Anaconda distribution because it comes with Python and all the different libraries, and they also manage the different libraries so they are compatible with one another. But one library that many people nowadays use Jupyter Notebook, but one library that is really an improvement on Jupyter Notebook is Jupyter Lab, that has a lot more functionality than a typical Jupyter Notebook. Is I would say the next step after the Jupyter Notebook. And you should also install this library. So how to install? If you use pip and you are not in Anaconda, you need to install, you can install more than one package at the same time. So you can install JupyterLab, Pandas, and Numpy in one single line of command line. So if you are on Windows, is the command shell. If you are on the Mac, is the terminal application. So you can just pip install and list the libraries that you're installing. If you have Anaconda, then Pandas, Numpy, sklearn, the matplotlib, they're all present in the distribution, the Anaconda distribution. So you just need to add JupyterLab. That is not a standard library in Anaconda. You can do just conda install JupyterLab. If there's a problem to find, you can do conda install -c conda force JupyterLab. It will look in another repository for the JupyterLab library. So you should first check if you have these libraries. One way to check on conda is to do conda search, package name, for example, JupyterLab --info. It's going to show you if you have that package installed or not. If you don't have conda installed, you can use pip and just do pip show and package name. For example, pip show JupyterLab. If you want to do directly from Python, you can do Python -c and then import package name. And it's going to have an error message if you don't have that package. So to start the Python program that we're going to write on JupyterLab, you should, on the command shell on Windows and on the Mac terminal, on the Mac, just type JupyterLab. And then later on, once we are finished to close, you just type Ctrl+C, you close the browser window, you type Ctrl+C in the shell, in the command shell or in the terminal, and it's going to ask if you want to finish, you say yes, and it will be done. So now we're going to move over to the live coding. I'll take a look now if there's any comments from you before we start. So let me just take a look here at the chat. So I'm just taking a look. So there's some people have network issues. I don't know how to help that, but other than that, let's go ahead. I suggest if you have network issues that you restart. That sometimes solves this problem. So let's stop sharing, because now we are going to move to the live coding. Okay, so I suggest that you install JupyterLab. If you don't have JupyterLab, if you have only Jupyter notebooks, it's no problem. You can work with Jupyter notebook as well. That's no issue at all. But JupyterLab, it's good that you start using JupyterLab because it gives a lot of more functionality than a typical Jupyter notebook. So let's now move on to the live code. So we are going to see how to do all that we talked about. Let's then now I will share my screen of my JupyterLab. I have already typed Jupyter space lab, and then I get to this. So this is now the Jupyter notebook inside JupyterLab. It's an environment that offers more functionality, and you can see it from here. So we are going to start by first make a comment, and the first part that you should always do is import the libraries that you're going to need. So this, of course, when you are doing for the first time, you may not know. There'll be some libraries that you're going to need, you only find out later. But afterwards, once you are finished, you should always move all your imports to the beginning of the notebook, because in this way, you can easily find out which libraries are needed for your notebook. If somebody reads, or whether you read after some time, you're gonna find out what should I have to run this notebook. Okay, so I always recommend that you put all your libraries in the beginning of the Jupyter notebook. So let's start now importing our libraries. As I said, if you don't have, so please, I highly recommend that you code along with me. If you don't have Jupyter Lab, don't worry about, you can just start Jupyter Notebook. It will work as well. It's just that Jupyter Labs offer additional functionality, as you can see here on the right of each cell. I'm not going to enter in a lot of details about Jupyter Lab, but it offers a lot of more functionality. So let's first import, because we're going to plot the precision recall curve. We're going to import matplotlib. So import matplotlib, pyplot as plt. Then another one that we're going to need is Numpy. So import Numpy as np. And then we come now from that sklearn. This library comes standard on Anaconda. If you have Anaconda, it's already installed. Otherwise, you can use pip install sklearn. So that is sklearn. We're going to import datasets from sklearn. And because we are going to use the datasets to have some data for our binary classification. And we are going to, for this binary classification, we're going to use logistic regression. So we're going to import logistic regression as well. So logistic regression. And now we are going to also do a train test split as usual in any predictive analytics. We split the data in train and test. We train the model on the training data and test the model on the test data. So we're gonna also for model selection import train test split. Next, as I told you, we want to calculate the confusion matrix. What is very nice is scikit-learn, which is sklearn as abbreviation, has on the matrix, it has the confusion matrix. And what many don't know, because this came in the latest versions of scikit-learn, it has also a function to display the confusion matrix. So confusion matrix display is the function that display in a nice way, like in a table with colors, the confusion matrix. And the next is, of course, we're going to need is we're going to use afterwards is the precision recall curve that we talked about. We're going to see it live, and I'm going to see how to find the best threshold in the precision recall curve. So now, once we are done, let's just set some parameters for the matplotlib package. So now let's start already with the code. No, so let's do that. We don't need that right now. So So let's start by creating our data set. It's going to be an artificial data set, but it's going to be close to any public data set. So data set, we're going to data set, and we're going to create a classification data set using the functionality that sklearn offers us. So we're going to create with 1000 instance, and here informative equal 5, and we're going to have a class separation. I'll put this on there. A class separation of 0.4. So there'll be 6% belong to one class and 0.4 belongs to another class. I'm going to show you the data set very soon. So let me just, so here we create the data set. So if we see the shape of X, we have 1000. Here's 1000, the number of rows, 10 is the number of columns. So if I do shape X, sorry, X. So what is nice when I create this artificial data set is that I can already give the X and Y. So let's see the first rows of head. Oh, sorry. Oh, no, so X, 3, because it's not a pandas. So these are the first 3 rows. You see, just randomly generate numbers, 10 numbers for each instance, because I said here 10, and there are a total of 1000 instances. And each of these instances here, these are Numpy arrays, each one of these instances, I have the first 3, they are associated with a label, and the label is the class where they belong. And here in Y we have the labels. You see, so the first 3 instances belong to the class 1, and 1 is so the Y is either 0 or 1. It's a binary classification, and there is a class separation of 0.4, means 60% belongs to one class and 40% to another class. So now let's do let me just do one thing here, just to make it clear. We call this read the data, read and explore the data, reading and exploring the data. So we divide our Jupyter Notebook in different sections. And now let's do the here split the data into training and test data. We're going to do the split here. So as you see, we are not going to do a lot of exploration in this data because it's artificial. Our goal is not to show you in this webinar how to explore data, how to do feature selection, how to do feature engineering. Our goal in our webinar today is about the classification itself, how to get the best threshold to check what is a confusion matrix, what is precision recall, to show you the precision recall curve. So the data exploration, the feature selection, feature engineering that you need with a data set, with a real data set, are not of concern to us today. We're going to focus on the classification itself, how the classification is done, how the threshold changes the classification. This is our focus today. So we are going now to divide the data in, so I'm going to divide it using the train test split to divide and in test and training. So here, typical, so this, the train test split returns 4 values, the X train, the X test, the Y train and the Y test. So what you need to give is just X, Y to do this, and then test size equal 0.3. So now with this, we split the data, and now we have X train, Y train, X test, Y test. So now the data is split in test and train, as we should always do. Just to remind you, it's very important, this number 2. There's one step missing here, that is the feature engineering, the data preprocessing, the feature selection. We're not going to do it today because this is an artificial data set. All the values are already numeric. There's no issue with missing values, anything. We don't worry about this today because our focus today is in the model classification and not in data preprocessing and feature engineering selection. So now let's then move on to the next step is we're gonna do the model fitting. So fitting the model to the, we're gonna fit the logistic regression model to this data set. This is another section. So CLF, the classifier is gonna be the logistic regression that we imported here above. So the logistic regression, I'm gonna just do it to be a bit easier for you to make a little big. Now the maximum I can go. So logistic regression. And now next we are gonna fit this classifier logistic regression to our model. So X train and Y train. So X train is this instance, and the Y train says to which class this instance belongs to. Since it is a binary classification problem, they either belong to one or other class. So let's run this. So, okay, this has run. Let's take a look at the shape of the Y test. So the Y test is 300 because we split here in 0.3. So the test size is 30% of the total. The total is 1,000. The test size is then 300. So let's see again here the first 3 values, the first 5 values of the test set. Just to look here. They should be the 0, 1, of course. And now let's do our first prediction. So now we're going to predict the classes on the Y test and compare our predictions with the 2 values, which is in the Y test. So the test data set has 300 instances that are all numeric. You can see here, let me just show you the Y train, the X test. These are the instances. If you see, like, again, like the first 2, they're all numeric. And we have the labels in Y test, and we're going to predict these labels out of these instances using this model that we trained on the training model. So to do that, let's see our predictions. Our predictions are going to be then equal to, we use the classifier and the predict to make our prediction. So here, if we see our predictions, let's see the first 5. you can compare, you see, the first 5 is correct, and there was correctly predicted. The first 5 looks exactly like the first 5 in the Y test. So now let's create our confusion matrix. So CM for confusion matrix, we are gonna call then what we just imported here above, this confusion matrix. So here, confusion matrix, and here we are gonna give, so confusion matrix is gonna compare the real values that are in Y test with the predicted values that are in predictions. And the labels that we're gonna use are in CLF classes. The labels are what? 0 and 1, okay? Because in other cases it could be different. It's just 0 and 1. So we have them here in CF classes. So let me just show it to you. If I do CLF classes, these are the labels. Okay, so we need to tell to the confusion matrix what are the labels. So these are the labels. So we are going to compare what is the real values and what are the predicted. The real classes for each instance and what are the predicted classes for each instance. And this is the confusion matrix that are going to compare the two. So now we have a confusion matrix, and we're going now to display what is in the confusion matrix. To do this, we use the confusion matrix display that we imported here above, confusion matrix display. And so now, what we need for the confusion matrix display to display this confusion matrix is we need to say the first argument is which confusion matrix we're going to display. Is going to be CM, the one that was created here. And then again, it's going to need to know which are the classes. It's going to display the labels. So which labels is the ones that we have here, the labels. So CLF classes underscore is the labels. And that's all we need. So this is going to create our confusion matrix that's going to be displayed. So we need to plot it and do a PLT show. Now look at this. We have a very nicely displayed confusion matrix. As you can see, here are the true positives, 127. So the true label was 0 and it was correctly classified as 0. So what would be a very good classifier? It has all the values here in this diagonal, and the yellow and the green and the pink ones, they would be all 0. So there'll be no mistakes. So the ideal one, so the bigger the numbers you have in the yellow and in the green, the better. And these two should be as low as possible. What is in pink, in darker color. And here, the color here, it shows how high the numbers are. The closer to yellow, the higher they are. The closer to dark, the lower they are. So the classification here is not so bad. It's not perfect, but it's not so bad. And here you can see these are the true positives, the yellow. The green are the true negatives. The 30 is what? Is what was 0 and was classified as 1. So it's a false positive. It's positive, but it's false because they are actually 0. And the 31 here is actually 1. It was classified as 0. So it's negative, but it's false because they are actually 1. Their label is actually 1. So these are the false negatives. So we have 127 true positives, 112 true negatives, 30 false positives, 31 false negatives. So now this is what most people do. They stop there and they look at the confusion matrix. And this is where we're going to go further. We're going to work now with the thresholds, with the probabilities, and we're going to get different results by doing that, better results. So we're going to now have our predictions, but this time, so now let's call this, and just divide them, predict the classes now. So we're going to this predicting the classes with probabilities. The classes with probabilities. So now we're going to change the game. Now we're going to work with probabilities. Once we work with the probabilities, here, all the probabilities that were present, they were so taken that if it's equal to 0.5 or higher, it belongs to 1. If it's lower than 0.5, it belongs to class 0. But now, this threshold 0.5, we're going to change. We're going to have control over that, because now our predictions are equal to CLF. And now instead, so here I use predict, but here we are going to do something different. We're going to prob, so it means predict the probability. So it's going to, now what is going to come out, the predictions are no longer just 1 and 0. It's not going to use the threshold 0.5 that automatically place the probability 0.5 and up to 1, and those lower than 0.5 to 0. It's going to actually show the probabilities that the model finds that this instance belongs to 0 or to 1. And now we're going to take a look what prediction. So if you here on the top, as you remember, prediction was just 0 or 1, 0 or 1. But here we have probabilities and not just 0 and 1. So let's look at what we have here. So here we have probability. So for the first, as you can see, the probabilities, the first is belong to 0 and the second of belong to 1. So they add to 1. So each probability, these two here, they add to 1 because the total is 1 of the probability. But here you can see how sure the model is that it belongs to 1. He is 70% sure that the first instance belongs to 1. He is 89% sure, very high, that it belongs to 1. He is 0.33 sure, so it means it's actually 0, because then the opposite is here, what that belongs to 0. He is 0.79, he's 0.943. So here are all the probabilities that the model belongs to the class 1, and here the probability that it belongs to class 0. So before here on top, in this predict here, what it does, it look at this column and see, okay, it's over 0.5, I say that is 1. If it's less than 0.5, like here, 0.33, I return 0. And if it's equal or higher than 0.5, I return 1. So now we have more control, because now we can see what are the probabilities. So what we really need is just the second column, which is the probability that belongs to class 1. So what we're going to do is just get the second column in the predictions. So now if we look at predictions, the first 5, so we have the first predictions. So what we have now on the predictions is just the probability that the instance, the first, the second, the third instance belongs to the class 1. Now, since we have this, we are able to calculate the precision recall threshold. So here, precision recall. So now we're going to see out of this how to calculate those measures that I told you about, the precision, the recall. And what is nice is it's going to also return all the different thresholds. So we're going to create now a precision recall curve. So thresholds. So this is, so it's going to give for different thresholds, what will be the precision and what will be the recall. So the precision recall curve that we, as you remember, we imported here above from matrix precision recall curve. So the curve is here. And now what we need is then the y-test and the predictions. And in this way, we just a moment, I need to place this window away from me. Just close this window here on the left. Just a moment. So, okay, now we have here. So now, let's see, now we have different precision and recall values for each different threshold. Let's just take a look here at thresholds. You see different thresholds. This threshold means if it's over 23, it belongs to the class 1. If it's over 24, it belongs to class 1. If it's over 36, it belongs to class 1. And here the precision, you're going to see the corresponding precisions. So in this case, the precision is 0.47. In this case, the precision is still about 0.7. In this case, the precision is still 0.7. Let's see the recall. Oh, sorry, recall. So look at this. Now, for this first case, where it's 23%, the recall is 1, the value of the recall. And here the value of the recall is 0.99. And here, so the recall, as you can see, the trade-off, when the recall is very high, the precision is low. And these are the, so you see for different thresholds, we have different precision and recall values. We're going to plot this. So you're going to see what it looks like. Now let's calculate our F-score. So now here, okay, let me just to make it clear, we're gonna here create a new section. Okay, so new section. So precision, recall, and F-score, and here the precision, recall. Cube. Let me just see if you have any question. Let's go here to chat. Can you, which data set we have to use? Okay, so the question I had was from before, just how to install Jupyter Lab is, as I told you, Conda install Jupyter Lab. Or if you want with pip install Jupyter Lab, I showed you in the slide. The other question is which data set we have to use. We create an artificial data set because our goal is not to work with any data preprocessing, feature selection, is to show you how to work with the classification. And the other question is, can you please share the recording with us? I think it will be available. Yes, I will, the recording. Then you can go slowly through all that I said. So now we have the precision calculated, the recall, the different thresholds. So precision and recall for the different thresholds. And now we're going to calculate the F score that we talked about. So the F score is, as you remember, just for you to see the formula itself, is 2 times the precision times the recall. We're going to use the form so you see it clearly, divided by the precision plus the recall. This is the formula to calculate the F score. So the F score takes both in consideration. So it's 2 times precision times recall divided by precision plus recall. And this is the F score. And I can have the F score for the different values. So here for each different threshold, I have different thresholds. I have different, for each threshold, I have a precision, I have a recall, and I have a F score as well. So you can see the F score now for the different thresholds. But now we want to find out, the question is, that is our question. We want to locate where is the largest F score. So let's put like this. So we want where is the largest F score, you know? So our goal is to have this F score as high as possible, okay? Because the higher the F score, the better the classification. But where is this? You know, in the middle of all those different F scores. Coming back to what I said before, why we have so many different F scores is because there is a F score for each precision and recall that is calculated based on what? On each different threshold. The threshold is 23%, here is 24%, here is 36%. This is the reason why we have different F scores, okay? But now, where is it? So we are going, so where is the largest F score? So let's first find the index. So let's find the index of the largest F score. So let's find the index here of the largest one. So what we're going to do is this is simple with Numpy. The index is Numpy argumax. So it's going to look in this list of scores. What is the index of the highest? So this is the highest. So let's see what YX. So it's the number 165 here in this list. It starts with 0. So that is where the highest is. So let's just now print in a nice way what it's about. So that's the print. So the best threshold is where this F score is, okay? So now we found the best threshold is the threshold. This is a big moment now for us, is we have found a way to calculate, let me just say this very clear. Let me get this right. So the best classification, result, no, is, or the best classification is where the F score is highest. So that gives you the best classification, gives the best trade-off between precision and recall. So the best classification result is where the F score is higher. And so we found the index, But we don't want that. Okay, we know where is the highest F score, but what do we want? What we really want is the threshold. So where is the threshold? So this is the question. So let me put here. Where is the threshold that brings us the highest F score? Well, since we have these lists, it's not hard to find. So let's just print now. So it's in a nice way. So best, I think you can guess, right? Where is the threshold that brings the highest F score? Where it is, just think about. Well, it should be in the same position where the F score, the highest F score is. This is why I did not look for the highest F score. I look for the position, the index, because this index of the largest F score is also the index of the largest threshold, because this list is for this threshold, this precision, for this threshold, this recall, for this threshold, this F score. So when I have the highest F score, I should have a value for recall at that same position, a value for precision in the same position, and a value for the threshold, the optimal threshold that brings me the highest F score, that brings me the best performance of my model. And that's, so the best performance, let's put the best performance of my model is where the F score is the highest. So now let's just locate it. So the best threshold, let's say F. So the F score is, we're going to display with 0.3 F. There's the threshold. And now let's see where they are. So is, oops, is thresholds. Look where it is. I'll put this like this, and then we'll see it in a moment. So the highest F score is where the index is, because the argmax in Numpy brings me the index of the higher value in this Numpy vector. So this is the position. Ix is the position. So here, let me just do one thing, because this is very important to understand this. So F score by X, that's the highest value. So the highest value that I have for all the different thresholds is this one, and is the position 165. So let me do it then. So here I have Yx. So where is the best threshold? The threshold that brings the high Ix is in the same position, okay? So the threshold that brings the highest F score is in the same position. So the best threshold, let me see here, the best threshold is this one. Look, the F score is 0.99, which is the highest, as you can see. The highest in all these F scores that we have. And these thresholds, in this case, because they depend on your model, remember always this, in this data, it depends on your data, actually, not on the model. It depends on your data, okay? So for each data, there'll be a different threshold that is the best. So the best is not at 0.5, it's at 0.99. 525474, about 0.3. So, but just change it from 0.5, the threshold, to 0.525, I have the best performance of my classification model. And now, what is very nice, what we're going to do next, we're going to show this because we have so many values here, right? So we have here a lot of values in these vectors equal to the number of instances in the test, which is, we have it here above, so we have 300. So we have 300 values. It's not nice to look at 300 values, you know, if I just do, for example, F score and don't do anything, you know, there'll be, wow, lots of values, right? It's not easy to see. If I do as well, if I just type precision, I'll have 300 values. That's not very good to see. But then, what is the best way? Through visualization. So let's now visualize. Let's visualize the precision. Visualizing. This is what, so let me just put this here. This is number 8. Visualizing the precision recall curve. So what is the precision recall curve? Is the different precision recall values for each threshold value. But now we're going to visualize the precision recall curve with the optimal threshold. So this is then H. So now we're going to see it, instead of looking at so many numbers, we're going to see it visually. So let's start by defining what would be the noise skew. I will explain to you in a moment. So the noise skew is the dummy classifier. The dummy classifier will have we'll just classify everyone as 1 or 0. So this is as 1, and this is the dummy classifier. And this is so here, I'll explain to you in a moment. This is the noise skew. It's just the length of y test. How many of the y test correspond to y test equal 1? You see, I'm just saying like everyone is 1, you know, and I compare this to the number, to the total of the y test. So this is the dummy classifier. If I want to be the dummy classifier, I just say, you know, would you have a very high accuracy? I would say, for example, in a spam mail or in a case of a disease, I say everyone is ill. You know, if I know that the majority is not ill, I would say they're not ill. You know, so well, if the majority is not ill, I'm going to have a very high accuracy. If the majority is not fraudulent, I'll have a very high accuracy, calculating the accuracy of my fraudulent prediction. So this, I just see how the percentage that is 1. And now let's plot. So PLT plot. If I'm going too fast in the coding, just let me know and I'll go slowly, because there'll be, now we're gonna do the plotting. So no skill. No skill. So we're gonna have a line from 0.1 to this value, that is the dummy classifier. And here, the line style, just to make it easier to see, is dash dash. And the label, so we know what it's about, is no skill, which means dummy classifier. So this is just a line for the dummy classifier. What will be the result of the dummy classifier? And now let's plot the recall and the precision. Because we have all that list, so recall against precision. And now to make it distinct, we're going to have a different marker for the recall versus precision. The mark is going to be a dot. And the label is the logistic model that's created. These recalls and precision, logistic. So, okay. Do you have any questions at this point about we're going to have all the Q&A at the end, so you can ask me any question at the end. I hope that you are also coding along. It gives a much better feeling for what is happening. And since there'll be a recording, you can review what I said about precision, what about recall. We can, I'm going to also, afterwards, we're going to just take a quick look again at precision recall, so remember what they mean. But now let's first do our precision recall curve. Why there are so many values for precision and for recall? It's because each value is for each threshold. Okay, just reminding you of that. So now let's do a scatter plot of recall. Now this is nice. This scatter plot here is of the optimal threshold. Let's see the recall at that point, which is y-x here. So y-x is where the f-score is highest and where we have the highest, the best threshold, not the highest threshold, the best, the one that brings the best performance in the model. So here we are going to plot that is recall and the precision y-x. And to make it distinct, we're going to use a different marker. We're going to use O. And to make it really distinct, we're going to use a color of black. And we're going to need a label. So the label, we're going to use a label as well. Label. So I'm going to bring this up so it's easy for you to see. So I'll close this for now. Okay. There's no, okay. So label. So label is going to be best. So best. Okay. So let's see. This is the dummy classifier. That just says everyone is of the same, is of one kind. Here is our precision against recall for all the different values of the thresholds. Here is the place where we have the highest f-score. This is y-x. And we're going to mark, so this highest f-score is where we have the best threshold. We're going to mark this place with best. And next, we're going to now just label the different x. So x label is going to be recall. So recall. Because we are plotting recall against precision. And then the y label is going to be precision. here is to show the legend. The legend is what we have is the labels. There'll be no skill for this plot. There'll be the label Logistic for this plot. And there will be the label best for this point. It's just a point because it's just two single values that are going to meet. So it's going to be a point in the chart. And now we're going to do PLT show. PLT. Okay. Yeah. Look at this. Now that it's a really nice. This I mean, in every project that you have, I highly recommend that you create such a plot, because this plot is very valuable. It will give you your best model performance. If no, but there's just one thing to remember. If this is the best compromise, what is this best threshold? Is the best compromise between the precision and the recall. You see, we have different precision and recall values. They change. No, you can see that when you have high recall, low precision, high precision, low recall. Oh, high recall, low precision, high precision, low recall. There's a trade-off. One is high, the other is low. But the best point is here. You see, that is that is the marker that we have that shows the best precision recall, the precision and recall that is best because is where the F score is highest, and that is the threshold that brings the best F score and brings the best compromise. But if you are in a case, where precision is more important than recall, then by all means, choose the highest precision. If you're in a case where the recall is more important than precision, then find a threshold that brings you this compromise that you want a higher recall, because it depends on which case. But if you don't mind, if the precision or the recall is not more important to you, if the most important is the balance between the two, here is the optimal threshold. The threshold that brings the highest F score, that brings the best combination of precision and recall. And there's this point here, which is this threshold, 0.52, and this is score. Let's see what is the value of the precision at this point. This is 0.82, so you have 82% precision. So it's right here, 8.2, H2. And now let's see what is the recall. The recall is 77. So that is exactly about here. That is this one here. That's right here, just before the 0.8. So these are the best precision and recall combination that I can have with this data set. Remember that any data set will have totally different values, but it's the same methodology that you can apply to one or the other. It will be the same, okay? Either one or the other, you have the same methodology. So let me just go through over again so you understand all the steps. And then we're going to review again what is precision and what is recall, because I know it's very confusing. Many people, they don't understand what it is. So we just imported the different libraries. Here we create an artificial data set with 1,000 instances and 10 columns. And we did the class separation 0.4. So 6% belongs to one class, 40% to another. And then this is what it looks like. These are just numbers. As I told you, We don't talk about it's very important, data preprocessing, feature selection, feature engineering. We don't need them here because this is an artificial data set with no missing values, with all numeric values. We don't need here. And because our focus here is not on the data preprocessing, is on the classification. So here we define the set in train and test. We can see that the Y labels that were created here, they are either 0 or 1. So now we apply a logistic regression model, and we get to see the result. So we have, if we fit this model to the X train, Y train, if you try a different model, I recommend that you try a different model like SVM and decision tree, random forest, and see how these results change. But using a logistic regression, uh, we see that, so what I mean by these results changes, you get a higher F score, okay? So our measure is a higher F score, but the highest F score with the best threshold. This is our measure. So here's the X test, Y test. Here's how usually people predict the classes without looking at the thresholds. They just use the predict of the classifier, get the predictions, and then you can use a confusion matrix. And using the confusion matrix, you see the results. That is where people stop. You know, they do this and say, well, we have a good or bad confusion matrix. The better is if you have as low as possible that here on this diagonal, and the highest possible here. The best is when this here is 0 and when this here is 0. But now this is where we went further. This is where we started to work with the probabilities. Here we do the probability of the classes, and here is where we get probabilities on it. We don't get 0 or 1. We get only probability, is the probability of being 0, and the second is the probability of being 1, belonging to class 1. Here is of belong to class 0. The sum of the two is always 1 at each line, because the sum of the probabilities must be 1, because it's either 0 or 1. And then we get just the second column, because the second column here, this list, is the probability of belonging to the class 1. So this is the probability of the first instance to belong to class 1. This is the probability of the second instance to belong to class 2. This is the probability of the third instance to belong to class 2. So if we had, as before, just 0, 1, this would be 1, this would be 1, and this would be 0. And this will be 1, and this will be 1. Really? Okay, let's just take a look. Look at this. See? So since I use a threshold of 0.5, exactly this 1, 1, 0, 1, 1, which is exactly because this one is higher than 0.5 is 1, higher than 0.5 is 1, lower than 0.5 is 0, higher than 0.5 is 1, higher than 0.5 is 1. So now, since we have the probabilities that it belongs to the class 1, we can use that, the two values, the Y test, and these probabilities, now these are different probabilities, these are probabilities that it belongs to class 1, and create a precision recall curve, which is what? We have a list of, we have a precision, a recall for each threshold. So we have different thresholds, and we have precision recall for each of these thresholds. Here we see the different thresholds. Here this threshold means anything that is higher than 23%, higher than 0.23 will be 1, lower will be 0. So these are the different thresholds. Here the different precisions. Here the recall, okay? Just to remind you, here is actually 0.02, so multiplied by 100, this is 2%. So it starts very slow. Here the threshold is 2%, here is 2.4, here is 3.6%, it goes all the way up. So here we have the different precision for these thresholds, the different recalls for this threshold. It starts from all the way very low to very high. And here's the F-score. The F-score is the best combination of precision recall, the best trade-off that you can have with precision recall. And this is the threshold, or the F-score for each different threshold so that we have here. So what we want, what is our goal, is to find where is the highest threshold. So using argmax, I found the index of the highest threshold in this array, and is located at position 165. And if you use this position, you get the highest threshold. Oh, the highest F-score, sorry. But our goal is to find out which threshold brings this highest F-score. So what we do, we use the same index to find the best threshold, which is this one. So it means that you should use not 50%, but 52.5 as the threshold to get the best performance of this model. And now what is very nice is here, we visualize this. We visualize how the precision and the recall change according to the different thresholds. So first we plot this dotted line, which is the prediction that everyone is one. You see, so the prediction of everyone as one compared to the top. And here we have then this, you see the value that they get. This is the dummy classifier. And then we plot recall against precision. And now here, recall against precision is this here that we see. These are many dots. So it becomes like a line, but these are dots, dot, dot, dot. You see, because the marker is a dot. So these are all dots. And the label is logistic. This is the one, the orange line. And now we plot as well in this line, where is the best combination of precision recall is the y-axis. That is the place where we get the highest F-score is here. And we have a marker here so you can easily see it. So this is the best. That's where the best threshold is. And we call the labels and we have it here. So here is the best precision and recall values that we can have, the best compromise between precision and recall. And the threshold that brings this best combination is here. Using the index, we have the best threshold for that combination, okay? So now we can have I can have your questions, and at the end, to finalize, I'm just going to go again through the slides so that you understand again very well what it means precision and what means recall, so that because people get very confused, and I'll show you again this in this slide. But now, please, if you have any questions, please just now feel free to ask. You can type in the text, in the chat, any question that you may have. So feel free to ask any questions. Oh, thank you very much. This is, for me, was really well explained. Thank you very much. Is Narendra Hatot, thank you. So anyone, if has any question, just ask me anything. And at the end, I'll just go again over the slides to make clear to you what is precision, what is recall, so you don't get confused. Many people get confused, that you get it right and that you know how to install Jupyter Lab. So Thank you again. Luigi Fernandes said a very clear, amazing explanation, no question at all. Kriti Avashi, thank you so much. Very clear. Everyone understood clear language as well. Fontaz Refa, Arati as well, Mohammad as well. Thank you so much. I'm glad that that is clear. So now just wait a little bit if anyone has questions. Otherwise, I'll go back to the slides to make a final review in the slides. Just to make the point, what I did here was with an artificial data set, but you should do this any data set and try different models, not just a logistic regression. You should try always different models because each case is a case. There is no model that works well in every case. So you should try different cases and see with the different models, what is the highest F-score you get for each model. So for each model that you try, you should check what is the highest F-score that you get, because that is the one that that brings the best performance of your model, and you should use the best threshold that you get with the highest F-score. So for each model that you try, you look for which threshold brings the highest F-score, and you choose the model that has the best highest F-score. And choose, of course, to get the highest F-score, you should use this threshold. Okay. So now let's go just back to the slides. I'll give you a last review of the slides. And now, with this, you can have the best performance of your binary classification model. You get the highest F-score by choosing the best threshold. That was our goal, and now you know how to do it. Then once you have the best threshold, just use this threshold in your model, and you'll get your best classification. So now let's go back to the slides just to review it before we finalize. Oh, sorry, I did the wrong one. So let's just stop the sharing, and now we'll move on to the slides, so I can show you the best. Let me just see if there are any questions here. Thank you so much. Okay, thank you too. So now let's share the screen and go back to our slides. So let's just go over quickly. So we saw what is a confusion matrix is. We saw what a precision recall F1 score is. We saw the trade-off. You cannot have them high, as you see in that chart. It goes like this. It goes, so there is a point where you have the best, but it's a trade-off always. And you saw that in the curve. We saw, well, we generated actually a nice confusion matrix that looked like this. Again, let's just repeat that you keep well in mind is a true positive is when I have another question. A question is coming late is from Ming Ho. Was a link to slides or anything else shared earlier? No, there was no link to the slides, but we can provide you the slides. You're gonna have the recording, and we can also, I'm gonna check this, but I think we can provide you with the slides. And since you came in late, you can now see this review of the slide. I will go quickly through the slides. It's a good opportunity for you, Minho. And now, since we're close to the end, feel free to ask any question. No, I stopped checking if there are questions, but if there are any questions, feel free to ask now. We're just gonna have a review now. So true positive is when the prediction is 1, is positive, and the reality is 1. So, okay, so my positive is true. So it's a true positive. What is false positive is when I said that is the predicted that is 1, that is positive, but in reality is 0. So in these 53 cases, I made a mistake. I said that they are positive, but they are actually 0. So this is a false positive. My positive is false. Now here, this is a nice one. I predicted 0, a negative that belongs to the negative class, and the reality is 0. So I have what? I have a true negative. And here I predicted that this instance belong to the class 0, but in reality, they belong to class 1. So this is what? Is a false negative. What would be the best case in the confusion matrix is very high numbers in yellow and green. This yellow green box in this diagonal should be as high as possible. In other words, there should be false positive, as few as possible false positives, as few as possible false negatives. So the highest here, but this doesn't tell the entire story. Just look at these 4 numbers. So this is why we have the much better, which is the precision and the recall. So we saw what is true positive, true negative, false positive, FP, and false negative. But the best is when we look at the thresholds and see using some better measures, because it's hard to measure, just look at these 4 numbers, they will change. The best is to look at the threshold, because according to the threshold, the classification threshold, we can have the best performance of our classification model. So then 0.5 is the best threshold. Is the 0.5 is the standard threshold. If you don't do anything like most people do, they will continue like this. They will have a performance that's not the best. The best is by finding the threshold that brings the highest F score, as we saw. So here's the definition of precision. These are very valuable because precision is the proportion of positive predictions that were actually correct. So this is very important. For example, let's say I have a case where it's very important that if I say something that is positive, that it is positive. So precision is very important. So I will not consider recall as so important as precision because there's a trade-off. For example, a case where I want to have a very expensive test, a medical test, if a person is ill. So if my model says that somebody is ill when it's not ill, that's not good, So it means that that I'm gonna have a very expensive testing procedure to see if the person is ill when the person is not ill. Many cases this will be used in vain. So you see, if the prediction of a disease is very important because you're going to cost a lot of money, then precision is very important, because if I have a lot of positive predictions that are false, precision is low, it means that I'm going to expend a lot of money. So this is a case where the precision is very important, because if my positive precisions, I need to make sure that when I say yes, when I say they belong to class 1, that in most cases is right. Now, going to recall. The recall is here. So the recall is of the proportion of the actual positive was identified correctly by the model. So now I'm looking, so precision, I say the proportion that the positive prediction that were actually correct. And here I want to see from the pool of all actual positives, the fraction of those that the model classified as positive. So now it's a different look at the data. No, now I just want to see out of those actual positives. Look at this, the difference now. Before I went to, it was like someone, do I lie when I say that it's positive? How many times I lie? If I lie too much, my precision is bad. No, and now with the recall, it's the other way around. Have I been able to identify how many positive have I actually identified? For example, no, imagine I want to avoid that some porno ads are displayed to children. So now recall is very important too, because I want to see how many of those porno ads have my model identified. In this case, precision is not important. What is more important is recall. So you see, depending on your case, either precision or recall may be more important. And you cannot have both high. You need to select which one you want to have high. So if for example, in a case that you want to find out as much as possible the positive that are in the data set correctly, like I want to find out as much as possible the porno ads so the children will not see them, then recall is more important than precision. Because you have a precision and recall trade-off, the higher the precision, the low the recall. So if you optimize precision, you will typically reduce recall. So if precision is important to you, you should just optimize precision and reduce recall. If recall is important to you, you should optimize recall and reduce precision. But if you have a case where you don't mind, you just want the best combination of precision and recall, then what you should do, you should look at the F score. The F score combines the two so that we have the best combination of the two of them, both precision and recall. But I want to remind you again that that is very important. No, not always the F1 score is the most important score for you. If you are trying to prevent children from looking at porno ads, wow, recall is much more important. No, in other case, precision may be much more important if, for example, you want to avoid when someone is ill that has a medical test that is very costly. No, so, or for example, no, you want a very high precision because you want to find out people who are ill and they need to be treated. No, and it's going to cost a lot, so it's precision. If you want to find out all those people that are ill, it's recall. If doing the test of people who are ill is very important, it's very costly, then you want to work on precision. So in some cases, precision is more important. In some other cases, recall is more important. You should always consider this, but in those cases where both are okay, you just want to optimize, you want to have the best precision with the best recall that you can get in this data set with this classification model, then you should use F1 score. And we have seen that we can have a precision recall curve that is calculated with all the different thresholds. We calculate for each threshold a precision and a recall, and we plot them. And there, where the F score is the highest, is where we have the optimal threshold. So if you don't care about either one or the other, that the precision is more important than recall, both are important. You want the best combination. You look for the model that brings you the highest F score for the optimal threshold. That will bring the best performance of your model. So just to recall, in usually case, you have all these steps that we don't need it here because our data set was artificial and our goal was more to look at the model evaluation, how we can best the best model evaluation. just to remind you again, when you do a project, the question is the most important. The question is the start of your data science project. What is the question I'm going to answer? And whether you have data available to answer the question, sometimes you don't have data available. And at the end, think about deployment and how to integrate this in the business environment, in the current way that people work, that your stakeholders work. Otherwise, you can have the best model and people will not accept because it does not integrate well with the way they work. Don't think only about the best model, the best performance. You need to think that first, start well your project, but by defining your question, by defining what is, you have data available to answer that question, what are your stakeholders, what are their needs, if they're asking the right question, and at the end, find a deployment and an integration that works well with the way they work. I cannot repeat this as many times as possible because this is the most important when you do a data science project. So what we did is we trained a binary model, we calculate the confusion matrix, the precision, the recall, the F1 score, we plot the precision recall curve, we find the highest F1 score and the optimal threshold that brings the higher F1 score for that precision classifier. You should try different classifiers and see what is the highest F1 score that you get among all those different classifiers. And we use Jupyter Lab. I recommend that you use Jupyter Lab. I didn't have time to show you all the advantage that Jupyter Lab brings, but it's much more advantageous than Jupyter Notebook. Jupyter Lab was made by the same people that created Jupyter Notebook, and it brings a lot more features to the Jupyter Notebook. And we use all those libraries and the sklearn as well, the scikit-learn. And as I showed you, if you use Conda, you have all those libraries. Only Jupyter Lab you don't have. You can do Conda install. If Conda cannot find, you can try this alternative repository. But usually will find with Conda install Jupyter Lab. If you don't use Conda, you can just do pip install Jupyter Lab. If you don't have Anaconda, then you may need to install yourself the other libraries. You can all install in one single line, as I showed to you here. To see what you have, if you have Conda, just do Conda search package name -info. It will show you information about this package if it's present. Otherwise, I will tell you that it's not present. If you don't use Anaconda, just do pip show package name. It will show you if this package is installed or not in your environment. You can do also directly in Python as well, instead of going through pip. And we did that, as I told you, once we started Jupyter Lab, just type Jupyter space lab in your command shell. If you're on Windows, if you're on Mac, is the terminal app. And later, to finalize, you close the browser and do you type Ctrl+C to finalize the application that is running on the command shell or the terminal. So I hope that, let me just close the share. So I hope that I have explained well to you, that you have understood everything, and that that you have no more doubts. This webinar is recorded. You can go over what I spoke before, and you can try out if you have not coded along. But as I told to you, don't look at a classification just using the standard default threshold. They will not bring the best performance on your model. Just look the threshold that brings the best F1 score. But keep in mind that depending on your use case, either precision or recall may be important. It cannot be both, but either one or the other may be more important. But if they are not, there's not one that's more important. The best combination of precision and recall you find in the F1 score. So you get the F1 score for the highest F1 score that you can get for the optimal. It will be the optimal threshold. Okay, using the precision recall curve. So I thank you for your attendance. I wish you a very good rest of the day. And I invite you to go to my LinkedIn page and follow me on LinkedIn and attend the courses of this institution, which is a very good educational institution. And you're going to learn a lot that you don't learn in many books. And one thing I can tell you at the end is that there are many data science books that are incomplete and that brings mistakes that don't call attention to the most important points. So be careful about which data science book you read. It's much better to have training in a very good institution like AIMT. So all the best and thank you. Bye-bye and have a very good end of the day. Thank you so much. Bye-bye.
Thank you, Paulo. Thank you for your time. And thank you, all of you, for attending the session. It was really nice to see all of you attending, spending time. And we are looking forward to seeing all of you into the programs that we are actually offering. So data science is, trending right now. So it's always recommended that you go ahead and learn it the proper way. And that's what we try to do. On that note, this is me, Sanket. Thank you once again. And thank you, Paulo. Any last words before we go ahead and end?
Thank you. Just that I wish you all good luck in your data science projects and that you take more courses, that you don't trust in any specific books. You take more courses for an educational company that is so good like EIMT. I wish you all the best luck. Thank you.
Thank you and have a nice day. Bye-bye.
Thank you. Bye-bye.